Hey, today we're going to talk about U substitution again. The difference today is we're going to talk about U substitution with definite integration, where you have an integration problem and you have both an upper and lower limit of integration. So there's two basic strategies for approaching such a problem. And what I need to tell you, it's not like back in the old days when you solve systems of equations and you could pick your own poison. You could do and solve a system of equations using substitution or elimination or graphing or matrices, and whichever one you were comfortable with or whichever one the problem led you to with regard to simplicity, that's the one you choose. Well, with definite integrals in using U substitution, you'll be handcuffed into knowing both of these strategies. One is utilizing X limits of integration, and one is using U limits of integration. So what we're going to do is one example today, and we'll solve it two different ways. Remember, the basic strategy for solving a U sub problem, the basic idea here is to set U equal to an inside function whose derivative appears. No difference at all with regard to solving a U sub problem as a definite integral compared to one with no limits of integration at all. So our challenge here today is finding the solution to a U sub definite integral problem using two different methods. Again, one we will use X limits of integration, the other we will use U limits of integration. We'll do them in that order. Let's take a look at the problem that we are going to work. Again, we're going to work the same problem using two different methods. So with this problem, we are going to solve the U sub integral using X limits of integration. Here is the problem. The integral from negative 2 to 0 of 2x plus 4 over x squared plus 4x plus 5 dx. Now I'm taking a look at that, and I want to know what I should set U equal to. I'm actually going to set U equal to the denominator here. The denominator is really an inside function. Think of it as being raised to the negative 1 power. And anyways, if you take a look at the denominator and take its derivative, you will see its derivative appear exactly in the numerator. So let's go through our U sub problem the way that we have worked it. Notice the integrand is written in terms of x, therefore my limits of integration are x limits of integration, and we're emphasizing that here with these definite integral problems. We're setting U equal to the denominator x squared plus 4x plus 5, so that du equals 2x plus 4, which we see in the numerator. So now we will rewrite this integral in terms of U. The integral of 1 over U du. Hopefully with your U sub experience, you understand exactly how we arrived at that new integrand written in terms of U. But what about the limits of integration? We're going to keep those limits of integration open for business right now. We're not going to steal negative 2 to 0 because those are not U limits of integration, they're X limits of integration. So let's just do the problem, forget about the limits of integration till we back sub back into X's. Then we can put those X limits back in. So my challenge now is to integrate 1 over U. Well, I know how to integrate 1 over U. That's going to be equal to the natural log of the absolute value of U. We don't have plus c this time, of course, we're working a definite integral. And We're not putting in negative 2 to 0 at this stage, as we are still writing our answer in terms of u. Stay tuned. So now I back sub. I put in the natural log of the absolute value of x squared plus 4x plus 5. And now I can evaluate that from negative 2 to 0. So again, when you're using x limits of integration with u sub, go ahead and do your u sub game, but do not include any limits of integration until after you have rewritten your answer with x's. Now you can evaluate it from those two x values, negative 2 to 0. Well, FTC1 says I'm going to plug in the top limit, the 0, wherever I see an x. Well, if you plug in a 0 wherever you see an x here, you're going to get the natural log of 5. Minus, plug a negative 2 in wherever you see an x. Well, I'm going to show you that work. If I plug a negative 2 in for wherever I see an x, negative 2 quantity squared is 4 plus 4 times negative 2, which yields minus 8 plus 5. So 4 minus 8, negative 4, plus 5 is 1. We're talking about the natural log of 1. We all recognize that the natural log of 1 has a value of 0. So my answer here is going to be natural log 5 minus 0, or a simple natural log 5. Okay, so notice, in solving this integration problem, this definite integral, using x limits of integration, I arrived at a final answer, natural log 5. Let's now do the same exact problem, but use u limits of integration. This time using u limits of integration. Here again is the original problem, identical to the one we've already solved. We again set u equal to an inside function whose derivative appears. In this case, that is the denominator of the integrand. I take the derivative of u and arrive at du equals 2x plus 4. It's now time to rewrite my integrand in terms of u. Check this out. I still get 1 over u du. But this time I'm going to use u limits of integration. Last time I included no limits at this part of the problem. This time I'm going to actually put in u limits of integration, because I know what u equals. U equals x squared plus 4x plus 5. So let's put in 0 for x. I'll get a new limit of integration that u equals 5. And then if I put in a negative 2 for x, and go negative 2 squared is 4, and 4, negative 2 is negative 8, plus 5, I get, well, you're already familiar with this. We've been down this road already. We get 1. So what I need to share with you is that our new limits of integration, instead of x limits going from negative 2 to 0, our u limits of integration go from 1 to 5. These are u limits of integration. This is going to be kind of simple. I mean, you've done the tough stuff. So I'm anxious to plug in these u limits of integration after I integrate to see if I arrive at the same answer as I did in the problem previous. Take a look. We get, when integrating 1 over u, we get natural log absolute u. And now we're going to evaluate that from 1 to 5. So again, FTC1, I'm going to put the upper limit in and then subtract, plug in the lower limit. In doing so, I'll get natural log 5 minus natural log 1, which may look familiar to you. Natural log 5 minus natural log 1. Natural log 1 again is equal to 0. My answer is natural log 5. My answer was natural log 5. So whether I use x limits of integration or u limits of integration, I get the same answer. You will find textbook problems, Foster test problems, AP exam problems, again, that handcuff you into using one or the other. You need to have a handle on both techniques. And so make sure you don't just opt for one or the other, whichever one blows your hair back. You really have to know both of these. So I would challenge you to work problems using both and not just one. And you'll find that you kind of gravitate toward one that you prefer. Again, you'll be handcuffed into having to know both techniques of integration, definite integration, using x limits of integration and u limits of integration. Know it, learn it, love it, live it. Hope this helps. Get some practice. Over and out.